In this video, we're going to continue with exponents and roots. We'll start by reviewing what we talked about yesterday, which is solving problems that can look something like this. And then we're going to talk about simplifying square roots. And then in the second part of class, we'll move on to some other things still related to this concept of exponents. So simplifying square roots. So let's start with review from what we did yesterday. We'll just jump right into maybe 2 examples, and then we'll go on to practice. So same thing we did yesterday. Yesterday, we might not have done anything with division. I don't remember if we did one like this, but we'll look at it today. It's very similar. So let's start with this one on the left. And so in general, you'll just be given a problem, and it might have some exponents, and you're going to want to think of different strategies you can try to apply to simplify it. And so you're looking for different things. And the thing we talked about yesterday was when they have the same exponent. When they have the same exponent, you can pull it off of both of them and put it on the outside. And the outside meaning, if you think of this whole thing being in parentheses, you can pull that exponent outside the parentheses. So here we're going to be left with the 8 times 1/2. And then now this exponent of 1/2 is going to be on the outside. Now we've freed up these 2 factors on the inside. 8 times 1/2. That's just 1/2 of 8, which is 4. If you wanted to set that up properly, to kind of be thorough with it, you say, okay, 8 is the same thing as 8 over 1. When you multiply fractions, multiply straight across. 8 times 1 is 8. 1 times 2 is 2. 8 divided by 2 gives us 4. Or like we said, you can just think of it as 1/2 of 8, which is 4. Now that we were able to do some simplifying, let's try turning this exponent into a root. So if you remember, 1/2 as an exponent is a root. And with just whatever number's on bottom goes outside the root like that. And that should not be a 3, that should be a 2. So if you remember, if it was, say, if it was 4 to the 1/3 power, that would be 4 cube root of 4. But here we have a 2 on bottom, so it's square root. And then what is square root saying? It's saying what number multiplied 2 times gives us 4. That's going to be 2. 2 times 2 gives us 4. So our answer here is 2. Now let's try this one on the right-hand side. So square root of 500, is that a perfect square? I don't think it is. I don't think 500 is a perfect square, but in any case, the same thing should stand out to us. Basically, that we have the same exponent on both of these. This one's just a little bit more twisted up because this top one, it's written as a square root. But like we just saw, square root is the same thing as 1/2 power. So that's just to say that we can rewrite this as 500 to the 1/2 power. The reason we want to do that is because now they have the same exponent, which means we can pull it to the outside. So we're left with just the 500 and the 5. And now this 1/2 is on the outside. So now let's go ahead and divide 500 divided by 5 is 100. So we have 100 raised to the 1/2 power. Let's change that 1/2 power back into a square root. Because we were able to simplify, maybe things will change now. And it looks like they did, because now we do have a perfect square. Saying what number multiplied 2 times gives us 100? That's 10. So our answer for this one is 10. So with that, let's move on to some practice. We'll try one with multiplication, one with division. So let's say we have square root of 5 times 5 to the 1/2, and let's say 18 to the 1/2 power over 2 to the 1/2 power. So let's go ahead and pause the video and give these a try. All right, let's have a look. So all these problems, the four we're looking at now, the two we already did and these two now, they're all dealing with square roots and 1/2 powers. Just remember that they could also be other numbers like 1/3, cube root, 4th root, 1/5 power, and so on. So let's first start with this one. Something that we want to stand out is that here we have a 1/2 power. Here we have square root, which are the same thing, which means we could try rewriting this as, or we can rewrite it to 5 to the 1/2. So 5 to the 1/2 times 5 to the 1/2. In this case, two things stick out. One is that we have the same exponents. The other is that we have the same base. So we could go ahead and just use that other property, which says, if you remember, we talked about it maybe like Monday or Tuesday. This property says if you have the same base, you can add the exponents. So you could do this as 5 to the 1/2 plus 1/2. 1/2 plus 1/2 is 1. So we get 5 to the first, which is just 5. So you can do it that way. And so again, when you're working with these exponent expressions, trying to simplify them, you're just looking for the different properties you can apply in different situations. So we could apply that one there. We also could apply the one we've been talking about, which is they have the same exponent, so we can pull it out. And so we're left with 5 times 5 on the inside, 1/2 on the outside. 5 times 5 gives us 25. We can change the 1/2 power into a square root. And the square root of 25, what number multiplied 2 times is 25? That's 5. 5 times 5 is 25. So we got the same thing doing it both ways. So don't think that there's a specific property you're supposed to use in some situation or that you have to use a certain one. There may be multiple ones that can work. Now letter B, 18 to the 1/2 over 2 to the 1/2. Here we notice they both have the same exponent. This one, they don't have the same base. So we can't do that quotient property where you subtract the exponents. But this one, we can do the one we've been talking about. We can take out the exponent because it's the same. So we're going to be left with 18 divided by 2 on the inside and the 1/2 on the outside. 18 divided by 2 gives us 9. So we have 9 to the 1/2 power. We can rewrite that 1/2 power as a square root. Square root of 9 is 3. Again, square root means what number multiplied 2 times gives you a 9. That's 3. 3 times 3 is 9. So there's a little bit of review. Now we're going to talk about something we haven't talked about yet, which is simplifying square roots. So we're just going to go through real quick and write down some perfect squares. Perfect squares are just the numbers that you're basically happy to see in a square root because there's going to be a nice clean square root. And we'll see what we mean by that in a second. So if you're not very familiar with these, and I think probably many of us are not, I would take the time to write these down just so you have them. So we probably want to know up to, we'll say 15. Just go through these. Maybe you already know some of these and you just want to write down the higher ones that you might not know. But it doesn't hurt to have all of them written down. So these are perfect squares. That means if they're under the square root, remember what square root means. We've just been talking about it now. Square root means what number multiplied 2 times gives us this number here. So all these are the numbers that are multiplied 2 times. So if we say, what's the square root of 4? We now know that's 2. If we say, what's the square root of 49? We can see 49, what number multiplied 2 times is 49? That's 7. 7 multiplied 2 times is 49. The square root of 49 is 7, and so on. So what happens? The question we're trying to answer now is what happens when you have something like this, square root of 8? So normally we're going through this list either on our paper or in our head, and we're saying, okay, where's 8? We have 1, 4, and then 9. We skip right over 8. 8's not one of our perfect squares. If you take the square root of 9, you get 3. If you take the square root of 4, you get 2. Because 8 is between these two numbers, that means the square root of 8 is going to be between these two. In other words, it's going to be 2 point something, and it's going to be a number that goes on forever. That's just how it works out. So this one, we're not really trying to find the exact value, or we are trying to find the exact value, but we're not going to simplify it completely by hand. Here's what we want to do. If it's not one of our perfect squares, which is the best case scenario, we're going to look to see if any of these perfect squares can multiply into this number. So we basically, if a number is going to be able to multiply in 8, it has to be either 8 or smaller. So we're really just looking at these two here. It can't be 9 because 9 is already bigger than 8. So it's going to be one of these. 1 can obviously go into 8, so we're really not that interested in 1 because 1 can go into any number, but 4 can also go into 8. So you want to find the perfect square that you can break it up into. And I think I'm talking around this a bit. So let's just look at some examples. And I think when we look at a couple, it'll just make a little more sense. So we're going to change square root of 8 into square root of 4 times 2. And maybe every time, we won't write this little 2 every time. If you remember, you don't have to write it when it's a 2. It's implied to be there. And we'll just take it away so it's a little less cluttered. So we broke 8 into 4 times 2. And then what we can do is this. We can break this apart like this, square root of 4 times square root of 2. And then 4 is a perfect square. Square root of 4 is 2. So we have 2 times rad 2. And when you have a number times a radical like this, you can just squish them up together like this, 2 rad 2. It's implied that they're being multiplied, so you don't have to write it. So we were able to simplify square root of 8 into 2 square root 2, or 2 rad 2. So that's what we're doing in this second part. We're simplifying square roots. So how could this apply to when we're trying to do all this different simplifying stuff? Let's say you had something like this, square root of 8 over 2, and we wanted to simplify that. Well, now we just found out that 8 is equal to 2 rad 2. So we could go through that whole process to simplify it, and we get 2 rad 2. And then it would turn out that these two 2's could cancel out because you have the same number on the top and bottom of the fraction, and you'd just be left with rad 2. So this can be another tool to help you simplify in different cases. Let's take another one. Let's say we have square root of 75. So we're going through our list of numbers, this column on the right-hand side. We're saying, first off, is 75 one of these numbers? And it's not. If we notice, it jumps from 64 to 81. Jumps right over 75. So not a perfect square. Next best thing is, can a perfect square multiply into this? So we're looking for any of these numbers that can go into 75. It obviously would have to be smaller than 75. So 81 is bigger than 75, so it can't go into it. 64 does not go into 75 by multiplying. 49, let's see, 49 times 2 would be 98. That's too big. 36 times 2 would be 72. That's almost, but not quite. Because if you multiply, or if you add another 36, you get, what would that be? 108. So not 36, but 25. 25 can go into, excuse me, 75 3 times. So we want to rewrite this as square root of 25 times 3. And we have this property which says you can split these apart to square root of 25 times square root of 3. Square root of 25, that is 5. And we can squish these together to become 5 rad 3. Let's look at maybe 1 or 2 more together. Let's say we have square root of 12. So we look at our list, and it jumps from 9 to 16, jumps right over 12. So 12 is not a perfect square. So we're looking, can any perfect squares go into it? So we're looking something basically over here, because 16 is too big. It can't go into 12 for sure. 9 can't go into 12. If you do 9 times 2, you'd be at 18. That's too big. And 4 can go into 12. So that's what we want to use. 12 is 4 times 3. We can split that apart. Square root of 4 times square root of 3. Square root of 4 is 2. We can squish these together to become 2 rad 3. Let's look at one more. Let's say we have, let's say square root of 98. So what do we think this one's going to be? Square root of 98. Our first question is 98 a perfect square? If it is, that works out nicely. When we look at our list over here, and it jumps from 81 to 100. So it skips over 98. 98 is not a perfect square. So we're looking for a number that can go into 98. So what is it going to be? Well, 81 could maybe go into 98. It is smaller than 98. But if you do 81 times 2, you're already at 162. So 81 won't work. And by the way, you can be using a calculator to check these out. Say, okay, what is 81 times 2? Too big. Now let's see 64. 64 is smaller than 98, so it could go into it. But if we multiply 64 by 2, we get 128. That's too big. How about over here, 49? If we do 49 times 2, we get 98. So that's it. That's the one that can go into 98. So we're going to rewrite this as square root of 49 times 2. Break it apart. Square root of 49 times square root of 2. Square root of 49 is 7. Squish it together. 7 rad 2. Let's go ahead and try some practice. Let's say we have, let's write this first, practice number 2. Let's say we have square root of 200 and let's start with an easier one. That one's actually probably easier than you might think at first. But let's start with square root of 18. I don't think we did that one yet. Maybe I'm wrong. But go ahead, let's pause the video and try these out. Square root of 18 and square root of 200. All right, let's have a look. So square root of 18, we see that our perfect squares jump from 16 to 25 jumps right over 18. So 18 is not a perfect square. 16 can't go into 18. If you multiply by 2, you're at 32. 9 times 2 would give you 18. So 9 can go into 18 2 times. So we'd say, okay, 9 times 2, break it apart, square root of 9 times square root of 2. Square root of 9 is 3. So we wind up with 3 rad 2 for letter A. Letter B, again, is not a perfect square. We jump from 196 to 225. It jumps over 200. So we're looking for what, if any of these can go into 200. And maybe it's possible that no perfect square would be able to go into your number, but we're picking ones where it's going to work out that way. So 196 can't go into 200, 169. If you multiply that by 2, you'd be at 300 something. This would be too big. And again, you can test all these out. So, okay, say calculator 144 times 2. What does that give us? Okay, too big. 121 times 2. What does that give us? Too big. That's going to be 242, I think. 242. And then try 100. 100 times 2. That's going to be 200. So we found the number we want. It's 100. So we have square root of 100 times 2, which is square root of 100 times square root of 2. Square root of 100 is 10. So we wind up with 10 rad 2. So with that, let's go ahead and move on to part A of the classwork.